Next speaker is a woman who kind of needs no introduction, Carmela Troncoso. She was one of the faces of the pandemic, and I mean that in a good way, actually. She's a key person behind the technology that is in the Swiss COVID app, which you probably all have on your cell phones. She is from Spain originally. She got her PhD in Belgium, and now she's one of us at EPFL, where she heads the security and privacy engineering lab. So without further ado, Carmela, the big, very big screen is yours.
Thank you very much, Bob. I hope you guys are hearing me. It is a pleasure to be here on the screen. I'm very sorry I cannot be there today. I'm actually quarantining because of a close contact. So I wanted to talk a bit today about how do we deal with privacy in machine learning and how do we think about privacy. And privacy is typically I don't know which slides are you seeing now? Because I'm not seeing my slides. Here we go. Voila. So privacy is seen as many times as a threat to machine learning, both because users perceive more and more that the amount of data we have to get to do machine learning is very invasive, and they start to feel kind of icky about it, as well as regulation that to make sure that users are protected and the users feel better are imposing more and more restrictions on what data can be collected, how it can be shared, how it can be processed. And the community has for a while worked on solutions that we call privacy preserving machine learning. Sorry about this, the remote control, not trivial, okay. So we have solutions for this, such as federated learning on the top left of the slide, where we see, that should be maybe top right for you? No, top left, because you're seeing the screen like me. Top left, where we have a central server that helps different devices to learn together. We have on the bottom right, the even more decentralized approach, where there is not even a central server and phones talk with each other or other devices to learn a machine learning model without having to give the data. We have on the top right approaches based on encryption, in which we use a central server, but we don't really give them data. We give them an encrypted blob, and still we can train a model, and analysts can make queries to the model in an encrypted way, such that private data never leaves the realm of the user. And on the bottom left, we have the other approaches, which we need to share data. Why don't we use machine learning to create what we call synthetic data? It's not a copy of the data, it's a version of the data that has the same characteristics, yet it has no connection. And these things are great because actually it would allow us to use machine learning. But from a privacy perspective, what is happening is that nowadays we have an adversarial model that is a little bit weak. We always consider an adversary, yes, but it is honest but curious. This means that the adversary will not misbehave, will follow the protocol, will not try to do evil things. And we also have a non-strategic adversary, meaning that the adversary is very rarely considered to actually know the defense and try to make the worst things against it. And the problem with this is that we have now seen in the last maybe 1 year, new articles appearing that show us that when the adversary kind of abandons this honest position and starts doing malicious things, so it may serve different values to different clients, it may craft different ways of computing the model, all of these privacy protections disappear. We have here works from the lab, from a lab in Toronto, works from my lab, in which we see how, machine learning, private machine learning is not as private in the face of malicious adversaries. And our own work also shows that in case of synthetic data, the strategic adversary actually will make all the synthetic data privacy property disappear. So the idea of synthetic data is that it is private because there is no one-to-one mapping. We don't have anything to do with the left and the right. In the left, you had the original data, you had names and then private information associated. This association disappears on the right. And if we consider the honest but curious adversary, this naive adversary, they may think we cannot make inferences anymore. But in our work, we show that if the adversary knows how this data is being produced, and the adversary does, because these kind of algorithms are known, it turns out that the information is still preserved. Because for the synthetic data to be useful, it needs to be statistically represented of the original data. And this is statistics, not the one-to-one mapping, what the adversary actually used. So the same attacks that we could do on the original data are possible on the synthetic data. And one may think, well, at this point in time, these machine learning algorithms didn't have privacy in mind, right? So it is kind of normal that we can really make these attacks. So what about if we add privacy on it, namely differential privacy? And what we also show in our work is that actually adding differential privacy is extremely hard. The amount of operations you need to do, the amount of assumptions that need to be met is very large. So what we have found is that in all libraries we have studied, each of them had implementation errors when implementing differential privacy. That meant that the privacy protections did not hold. And the kind of tricky thing here is that these errors in the implementation were actually made the privacy preserving mechanism not to impact utility. The moment that we fix the errors, we still have synthetic data, but now the synthetic data does not really resemble the original data anymore. That is because we have destroyed those statistical patterns that were useful for the adversary, but those were also the statistical patterns that were useful for the analyst. So again, the same attacks are possible, or we lose the utility. So what I would like you to take away from this talk today, this food for thought, is that when you're thinking about privacy and what privacy to put on your machine learning pipelines, you must think that the adversary is as evil and as clever as you may imagine. Adversaries are not honest. They don't follow the protocol. They actually do the opposite. They will change the protocol and they will change their actions to try to undermine your defenses. And they are strategic. They know what defenses we have put on the field. And they would, whenever they are not honest, they would actually take the worst action every time. And that means that getting privacy is very hard. And if we don't make these decisions, right, what we have is that this is not privacy. This is actually not a private machine learning mechanism. It may be compliance with regulation, and that may be the only thing that you need for your company, and that is good. But if we're gonna want machine learning to be safe when it is deployed for us as a society, we need to take a step forward. The second message is the synthetic data is not a silver bullet. If utility is preserved, if the synthetic data is as useful as the real data, so is the information that enables inference attacks. We have not solved anything. And if there is protection, what we have found is that protection is not uniform from everyone, and it is actually unpredictable. This comes from the randomness that is inherent to machine learning processes and more to the sampling process of synthetic data. We really will not know which of our users in the synthetic database are actually protected. And as a final note, whenever you do a privacy preserving mechanism for machine learning, please go and do empirical evaluations. Theory is very nice, but practice is very hard. Bringing theory to practice comes with a lot of errors. So please always double check, because this leads us to find errors in the implementations that get us to make better and more privacy preserving systems. And this is all I wanted to say today. I thank you so much for your attention. And if there is time for questions, I'm happy to take them. Otherwise, I'm sorry I cannot join for the coffee break and discuss, but please find me on my email or my Twitter account.